Cool. Yeah, great to be here. Very happy to kick it off in terms of embeddings and retrieval. So we'll make a connection why this are like very, very cool, interesting topics in terms of AI. So in my opinion, one of the most critical aspects of AI, and it's still pretty much unsolved. So there's a lot of room to improve, to innovate, to make better models, make better systems. So a bit about myself. Started neural networks, programming neural networks back in 2005, so 20 years ago. Had these small Lego robots, and we're putting like neural nets on them so that they could navigate in my room. And then in 2010, we did in school and in university, did a lot of like Pac-Man. So I had like a full semester training systems, AI systems to play Pac-Man really well. And then in 2013, I got the question, hey, is deep learning just a hype? A lot of people start talking about neural networks in 2012. And so in 2013, my task was to figure out, is it a hype that will die in 2013-14? Luckily, it wasn't a hype. It's still ongoing after 12 years. And so in 2018, as postdoc, has been working on text embeddings. And back then, it was like a very, very small community. So it was like one team at Facebook, one team at Google, and my lab, we were like looking into text embeddings, how to train them, how to improve them. And then in 21, joined Hugging Face, and in 22, joined Cohere, where I currently work as VP for AI and search. So you all know ChatGPT, but like in an enterprise setting, it's not really that helpful. So if you write a question like, hey, can you write me a job description for a backend developer team? You get like a very generic description, like, sure, here's a generic job description. I don't know which tech you're using. So just put like Java as required skill. Even worse in sales. If you have a question, what have we discussed with customer X or pricing? The Gen AI systems just say, hey, I'm sorry, I'm an AI language model, I don't know. And so what people have been starting shortly after ChatGPT came out is this Gen AI on your data. So you have the prompt, what have we discussed with customer X on pricing? And then you do first a search. So you have somehow organized your enterprise knowledge. You analyze the results, and then you put it into a generate model. And then based on the context, again, output, I found like 2 signed contracts with customer X and 3 projects with ongoing negotiations here. So this is like a very simple rack system that became popular in 2022 and is still relevant up to date. Just give me 5 seconds, need to close the door. Okay. So high search quality is really essential. So this is like what I focused the last 6 years on is how do you find the right information? So here's an example, gives me an overview of the Colin Raffle papers from 2021. And then it compares different systems, one from OpenAI, one from Cohere. And the challenge is like with OpenAI, it finds a lot of papers. So it was like searching over all of archive papers, but none of the papers is from like Colin Raffle. A lot of papers are not like from 2021, but like 2023. And then even if you have AGI, the response is like, hey, sorry, there aren't any papers published by Colin Raffle in 2021. Or the user thinks, hey, this is a lie, this isn't correct. And so what we're focusing a lot on is like on the search quality. If you have a prompt like this and you get like the correct responses, you get like the correct papers, it's like very easy for the generative model to say, hey, I found 9 papers that were co-authored by Colin Raffle in 2021, he mostly published on the topics. And this is especially critical for like enterprise AI applications. So for like a consumer AI application, if you have something like, hey, how many people work at Google? And then it does a search, it finds maybe a document from 2003 that about 1,000 people work at the young startup Google. The LM can internally fact check that this information is likely not relevant. So it will respond from the internal knowledge that Google has 180K employees. But for enterprise applications, it's much harder. So if you have a question like, hey, who's our manager for project X? And then it finds a document from like 2020 that says, hey, happy to announce that John Doe is the manager of project X. The LM thinks, oh yeah, John Doe is the manager of project X. But the user says, oh no, this can't be true. John Doe left the company 3 years ago. And they make kind of like a conclusion of the overall system, say, hey, this AI system is bad, cannot be trusted. Why is it saying that John Doe is still the manager of project X? I'm not using the system. And it doesn't matter how smart your LM is. If the input is garbage, the output will be garbage. And so what me and my teams are focusing on is really find the right information. So if you put in like, who's the manager for project X, find the right information wherever it's in your enterprise so that you can pass it to the LM. And yeah, it's nice to see that other people are also getting a sense that these context engineering is getting a lot more relevant. So here's a very recent tweet from Andre Karpati about, yeah, prompt engineering is nice, but like the real challenge is like context engineering. So when in every industrial strength LM app, context engineering is the delicate art and science of filling the context window with just the right information for the next step. Science because this right involves task description and explanation, few short examples, RAG, related, data, tools, state, history, compacting, too little of the wrong form, and the LM doesn't have the right context for optimal performance, too much or too irrelevant, and the LM cost might go up and performance goes down. So really, context engineering is like a big, big challenge. We even still fail as a field on like very simple context engineering, let alone for like very, very complex tasks. So how can you do the retrieval? One of the most basic technologies are embeddings. So they became popular in 2019. And what you do is you take your data, you present it to an embedding model. So an embedding model is some transformer model. And then it's stored in a vector database for efficient access. And these vector spaces are so-called semantic vector spaces. So you cluster the text based on semantic meaning. So at the bottom right, you have information about Mark Zuckerberg and Facebook. In the middle, about deep learning frameworks. At the top, the bottom left, about atomic numbers. And then when a query comes in, you project the text of the query also into the vector space. So when the query is like, who created Facebook? And then you find in the vector database these two entries. Facebook was founded by Mark Zuckerberg. And then you return these either showed as like search results to a user, or you use it as a context for the LM so that the LM can answer the question like, who created Facebook? I mean, for this question, you wouldn't need RAG, but if you have like, hey, who created this internal product, or who's the manager of this project right now in our company, you really, really need such an approach. There are a lot of challenges in embedding. So embeddings is like a very simple technology, but it has like a lot of flaws. One challenge is like topic match versus quality. So for example, if you search for like COVID-19 symptoms, for example, with the Open AI embedding model, the top hits are the following: COVID has many symptoms, symptoms are not nice, and symptoms are bad. They all match very well in terms of topic. They're all about topic on the same topic, COVID-19 symptoms, but it's not really helpful for like an LM to present these. And so what you want is like to find the most informative content on the topic. So, so in this case, kind of like, what are the symptoms? And what you do is like in these vector spaces, you, on the one side, you measure the topic similarity, but what you also want to measure is kind of like the quality. So in our embeddings models, we have kind of like separation of the vector space. So some dimensions measure the topic. Is it on COVID? Is it on programming? Is it on Facebook? And then others measure the content quality to give an indication, like, is it providing, how much information is it providing on a topic? And you could visualize this in like two dimensions. Let's say one dimension, the y-axis is on the topic and the x-axis on the quality. And then at the top, you have like information on COVID. At the bottom, information about machine learning frameworks. And then on the quality, we say, yeah, this text on COVID has a lot more information, is a lot higher in terms of quality than this text. So you put it like higher on the quality side. And then on the query side, when you send in a query, you say, I'm interested in like COVID-19 symptoms. So the model puts it at the right topic. And then on the quality side, you artificially set it to like, I want like the highest quality possible. So find me for this topic, the content was the highest quality. Same when you have a query like, which language should I use for machine learning? You just rank it on the topic side, and then on the quality side, you say, find me for this topic, the content was the highest quality. This is mostly done with preference learning for embeddings. So you have a query, you have two documents, those match on the topic side, and you ask humans, annotators, is document A or document B better for this query? And then you project this into the vector space. So when you train the model, you ensure that the similarity between the query and document B should be higher than the similarity between the query and document A. So this is like preference learning for embedding models. Second challenge you have with embedding models is like multi-aspects. So this was like a very, very simple vector space. Everything was just a sentence, but usually the documents we have, it's not just like one sentence, but it's like a paragraph, it's a page, it's a full document. And if you have a text like hydrogen has atomic number 1, helium has atomic number 2, and you project it into the vector space, the sensible position is between these two. So you put it in between these two embeddings. So that's a great position. But now some user writes something very crazy, writes bananas are the most sold fruit. Facebook was founded by Mark Zuckerberg. And this leads to catastrophic failures. So if now your search query comes in and say, hey, what is a good framework for deep learning? You see that the top ranked results is bananas are the most sold fruit. Facebook was founded by Mark Zuckerberg. And you as a user think like, hey, why do I get this result? Same as LM, if you put it into the LM thinks, how is this connected to deep learning? Are bananas a deep learning framework? And this is just due to coincidence, because this embedding doesn't have a good position. So it's the center position of like bananas are the most sold fruit and Facebook. So the center position really makes sense mathematically, but the center position is not empty, but there's like other information stored. And you see it very often that you get like very, very strange results. So for example, if you just use embedding search, semantic search, and you ask a question, when was the attention paper by Aidan Gomez published? You see a lot of different results, but there is not a single paper by Aidan Gomez. There is no attention paper in here, because you have like all these independent things that are embedded together. So for example, here you have the authors, Michael and Peter. It takes the average of these two names, and then by coincidence, the average of Michael Shikitia and Peter Diggle is close to Aidan Gomez. Same, you have like the dates, the times, some numbers. So a lot of like these multiple aspects that really puts a lot of like confusion in the vector space. And so a good solution here is a reranking model. So the reranking model can take these very ugly results and kind of like does a cleanup, finds the right results. So if you run the results with the re-rank model, It gives you at the top, like the attention is all you need paper, co-authored by Adam. And this is kind of like the common setup you nowadays sees for like many search applications. You have like millions of documents. You have the first stage search with embeddings or keyword search. This gives you down to like a top 100 list. And then the top 100 list, you send it to our rerank model. And this gives you like a reordered list. So before you had like these top 3 documents, which are completely irrelevant, but the attention is all you need paper was maybe on position, I don't know, 85. And then it goes from 85 to position 1. Well, in this case was like, yeah, rank 8, and now goes to rank 1. Cool. So it also gives like a massive boost in search quality. So this was a customer, a CRM software company. They had like a rack application on products and on data tables. And before they really struggle, like they ask questions about products. I don't know how much watch is this product using, or what's the screen size of that product. And they were retrieving like a lot of irrelevant results, things people haven't not asked for. And this was like really a struggle with kind of like the wrong retrieval setup. And then it narrows down into like the rack setup. So when the question was like on data tables, they could only answer before like 40% of the params correctly. And then after improving the retrieval, they were able to answer 80% of the over 80% of the prompts, the questions correctly. There's another challenge. So we talked about multiple aspects. We talked about quality. There are also other ranking signals. So let's say your queries like updates on AI. There are like different podcasts, the AI update and last week in AI. If you project it into a vector space, you would say, hey, the AI update is just the more relevant content here, the more relevant document podcast here. But there's other things. So there's a release date. The one was released in 2015, the other in July 2025. There's a rating, 1 out of 5 stars or 4 out of 5 stars, where you say, oh, the left one is kind of like in the vector space, the better semantic match, but the right one is the preferred search result. So it's not so much on the text, but it's like on the release date, it's more recent, it's better rated. Similar when you ask something like, hey, what's the company focus for Facebook? And you find like two statements. One is like Facebook should focus on better photo sharing options with friends. And the other is metaverse isn't a thing a company builds. It's the next chapter of the internet overall. You would, again, like tend towards the left one, like Facebook should focus on better photos sharing option with friends. So if you just see the query, just see the text, I would say the left one is the more relevant one. But the left one might be a quote from an intern in the first week at Meta. The right one is an actual quote from Mark Zuckerberg, CEO of Facebook. And what a CEO says is, automatically a lot more relevant than what an intern says, not necessarily based on the content, based on the text, but just back on the background, back on the position, on the power Mark Zuckerberg has in Meta. And so it's not just like what we write, but also like who said something. And this is like what we also need to take care into search. And we say, okay, this is like a more authoritative source. And even such, the semantic match is not so good. We prefer the more authoritative source over the less authoritative source. So if you ask what a search results makes relevant, there's a topic match where there's like a big focus with like all the embeddings, like just focusing on the topic match. But what's equally relevant for users like freshness, we want new information. We don't want outdated information. So if I ask like how many people work at Google, I don't want the information from like 20 years ago. Trustworthiness. So there's a lot of like wrong information, fake information. How can I really find trustworthy sources. Popularity is also helpful. So things that are more popular can be more informative than things that are less popular. And typically when you see something like, hey, what's the Google revenue? You have like one document that says Google revenue is 1 million. It's amazing in terms of topic match, but freshness is like very low. So it's like from 2006. Trustworthiness is also very low. It's some random comment on Twitter. And then on the other side, you have like Alphabet revenue for the quarter was 80 billion. On the topic, it's not so good. It's Alphabet, not Google. Talks about a quarter, not necessarily about the year. But it's from the SEC, so it's like very trustworthy. Freshness, 2004. It's not 2025, but 2024 is definitely better than 2006. So you really would prefer the right one, even such that the topic isn't that high. And so this is kind of like the challenge we need to solve and search. How do I find the most useful information, meaning information that matches the topic, but that's also fresh, that's trustworthy, that comes from like an authoritative source. Cool. Yeah, so in terms of questions, I will take the questions at the end, and then I'm happy to dive deeper into any areas. Yeah, training and retrieval models. So how do we train embedding models? So typically what we do is you train these with triplets. So you have a question, you have some positive documents, so a document that's preferred, that provides more, better information, and a negative document. And then you do so-called constructive training. So you project these three elements to the vector space. You want that the positive document is moved towards the question, and the negative document is moved away from the question. And then you have like all these triplets, millions and billions of these triplets. And over time, the model learns kind of like a good vector space so that the positive documents are close to the questions and the negative documents are all far away from the question. What you differentiate on the negatives is like easy and hard negatives. So an easy negative is on the left. You have a question. You have a positive that's already very close to the question, and a negative that's really far away from the question. The issue is like such a triplet doesn't provide like a training signal to the model. So the model already knows the positive is closer, is more relevant than the negative. So if you have triplets like this, the model is not improving. If you generate like 1 million of these triplets, it's not helpful in terms of the training process. So what we always look for is hard negatives. So a hard negative is the model thinks that the negative is more relevant to the question than the positive. And this is really highly valuable training data. But the challenge is how do we find these triplets? So how do we find these triplets where the model fails on? Well, the model already solves like 99.99% of query positive negative triplets, so these easy negatives. And so we spend a lot of time like looking into these remaining 0.01% where it struggles, where things like, oh yeah, this document is relevant than the other, but actually it's like the reverse. And we spend like a lot of time, engineering time, to look into these triplets, generating these triplets, finding these triplets, because then it always refines and makes the model better. So the more triplets you find of these hard negatives, the better the retrieval model gets. Another challenge is scaling retrieval. So one thing is for sure, we create ever more and more data. So over the past 20 years, the amount of data that's available in the world increases. And also going forward, there will be more and more data. And this is like a challenge in retrieval. Not only needs to be good, but it also needs to be cost efficient and fast at scale. To give you a cost comparison, let's say you do 1 billion documents, it's not that much. To compute the embeddings, it costs about like $50,000. it's a one-time cost. It's okay. It's a significant amount, but it's 50K. It's a one-time cost. But if you put it into like an unoptimized vector database, you pay $1 million per year for the vector database, and that's annual cost. And so this is like a massive cost driver that you have to take into account into production. So it's not necessarily always, hey, I have the best embedding model. It's super, super cool. But if it's like very, very expensive to run your vector database with this embedding model, you're not able to go into production, and you're not able to deploy like to like 1 billion documents, 10 billion documents, 100 billion documents. And so what we also focus a lot on is kind of like these quality cost trade-offs. One very interesting approach is like embedding quantization. So out of the box, you can say, okay, an embedding model maybe produce 1024 float 32 embeddings. The challenge, however, is if you put it into a memory, into a vector database, you need a machine with like 4 terabytes of memory. 4 terabytes of memory is still very expensive. So one option is to go with like fewer dimensions. So instead of like 1024 dimensions, you can use like 384 dimensions. You go to 1.4 terabytes of memory. Still quite expensive. Quality drops a bit, so it drops by 1 point. But then there are like ways how you can make it smarter. So one way is like to quantize to int8. So instead of like having float 32 embeddings, you go to int8. You can also go with product quantization and with binary embeddings. This drastically lowers your memory footprint. So you go from like 4 terabytes to 120 gigabytes. Quality also goes like from 81 to like 79. So there's a trade-off, and you always need to understand, like for every deployment, for every use case, do I need like the best possible quality? And then I go with like a very high dimensional float 32 embedding model. But in many, many cases, you say, okay, like this 1-2 additional points is not necessarily worth the cost of like a 30 times higher deployment. So it makes a difference if the vector database costs $1 million a year or cost just 10,000 a year. So binary compression is a very interesting one. So instead of like using floats for your vector space, you use bits. So you have like a very simple binarization. If the value is positive, you set the bit to 1. If the value in the embedding is negative, you set it to 0. This reduces the memory for the vector space by 32x. Also, comparing bits is faster than comparing floats. So you get like a search solution that's 40 times faster. But not all embedding models support binarization. So if you imagine like your vector space looks like this, you have like coordinates, 2 coordinates, x and y, and the vector space is like in the upper right. If you do binarization, all these 4 points would become a 1-1. And so the quality would be like very, very low. And you see it with like some models. For example, if you take from Microsoft the E5 model, or from Cohere the V3 embedding model, in like a float vector space, they perform very similar. So they get like very similar quality performance. But if you go to like a binary space, you see here a 20-point, 24-point drop in search quality. So it goes like from 100% to like 60% search quality. And with our models, it goes to like 90% search quality. And the reason is we dedicatedly trained the model for that. So normal embedding training produces your vector space, which looks like this. It's all in the upper right corner of your vector space. In a float environment, you don't have a problem. But what we do is during the training process, we have like these compression-aware training, that we ensure that the vector space is like nicely distributed over all quadrants of the vector space. So it's like nicely distributed in the vector space. And this drastically improves the search quality also for like other compression methods like PQ. Again, if you do it with a model that's not optimized, you lose 50% of your search quality, or you just remain 50% of the original search quality. But if the model was trained for these compression, it's like 85%. So it's not just get the best quality on this one benchmark, but make a system that's really production ready, that scales well, where the unit economics make sense. Okay, to conclude, so context engineering is critical for every enterprise LM application. So how do you fill the context with the right context? You don't want to add too much information. You don't want to add too little information. And it remains kind of like a really, really open problem. And like, how do I find the right context? So if you give LM the right information, like if you give it all the information that's necessary and just the information that's necessary, so it's kind of like an Oracle setting, we all know LMs work extremely well. But in reality, for all LM application, we provide too much information or too little information, useless information. It's like very, very hard to find the right information. Retrieval plays a critical role here. So where retrieval is used like documents with helpful information, kind of like these classical rec. Tell me what have we discussed with the customer on pricing. So it goes into your emails and finds the right information. But it can also be used for user information. So you might have like information about the age of the customer, the location of the customer, what contracts the customer has with you. You also want to maybe retrieve like few shot examples. So if the customer asks, could you please change the address for my bank account? You might want to give the LM at runtime like some examples how to do that. For past chat interactions, sometimes called memory, you can infer a lot of like user preferences. So if I go on like a ChatGPT and always ask about like, hey, can you write me a Python script on this? And can you help me debug this Python problem? And then I ask another question like, could you write me a script to sort my files? Based on the past chat interactions, the model or the system could know that I prefer Python, that I'm familiar with Python, and that for the new answer, the output should be also in Python. So if I don't specify the programming language, it should go into my past chat histories, find which programming language I like, and then generate an answer based on my past preferences. Also external tools. So in the beginning, it's like very easy to give the LM like all possible tools that exist, but very quickly you overflow the context window. You pass in like too many tools. The LM doesn't know which tool to pick. But with retrieval, you could narrow down and say, okay, for this prompt, it would make sense to pick like these 5 tools and hand these 5 tools to the LM. And we're very far from being solved. So context engineering, retrieval, still a super active, super interesting area of work and research. Embedding-based search systems, they work on simple tasks, but they fail very quickly. So if your system is just embeddings, it's so easy to fail. And we constantly need to improve and create better systems to find the right context to augment LMs with the right context for the task. Cool. That's so much of my presentation. Looking forward to Q&A.
Thanks. Can you see the questions in the Q&A section of meeting?
Yeah.
You can just show the unanswered. Click on the show and unanswered.
Cool. Should we do questions on Q&A or should we?
As you prefer. I can allow people to.
Yeah. Yeah, I mean, we could start like do like a mixture of like questions in the chat and then also questions for people who raised their hand.
Great.
Yeah, Tushar, you raised your hand. You want to start?
Yeah. Hey, hi, Nils. Thanks for the session today. I had this question. You mentioned this way of training the retrieval models by finding triplets, right? You mentioned about getting hard negatives in order to push the model to perform better. So is there a particular way in which you find those negative examples, hard negative examples? Because I remember a way of doing contrastive learning in the similar way with triplet laws. Is that similar to this?
Yeah, if you want to find these triplets, so how we do it is playing around a lot with our models. So we test the models, we use it, and then we identify areas where it struggles. So maybe we say, hey, it struggles if the query is in Arabic and the document is in Japanese. And then we go in and create triplets in the direction. So we know it struggles cross-lingual. So we create query in Arabic, first document in Arabic, or negative document in Arabic, positive document in Japanese. And then create these triplets and give it to the training mix. What's also popular is using more powerful models like big LLMs to clean your triplets. So big LLMs are quite powerful to clean the triplet. So you give a triplet and you ask, like, verify with the LLM, hey, is the positive really more more relevant than the negative? Please give me like a reasoning. And so it's kind of like an automated way where you create triplets, you mine triplets, and then have like some verifier to clean up your triplets.
Okay, thanks, Nils. There are a few more questions I have, if that's all right. So the second question is, you mentioned that current retrievers only focus on semantic meaning matches, right? So you said that the Cohere retriever also focuses on how recent the document is. So how do you give weight to those parameters while searching for a document? Is there like a weight matrix and weighing all the scores together, or is there another way, like waterfall model or something like that?
Yes, sadly, we don't focus yet on freshness and trustworthiness. So the embedding model has topic match and content quality. But freshness is like very hard because it really depends on the domain. So if you're like, I don't know, you're a day trader, or if you work on sports, you're interested in like the football results from like the last weekend, but you're likely not interested in like the football results from like 1998. So their recency is like extremely critical. If you say, hey, what's the latest results of my favorite team? It's super critical. But if you work in, I don't know, if you're a historian and you search like archives of like newspapers over the past 200 years, and you search for like documents there about like events happening in your city, their freshness might not be relevant. So there you don't care if like a document is 100 or 150 years old. So it's hard. We don't have a solution yet. No one has a solution yet. A lot of hacks are implemented. So if you know freshness is relevant, people kind of like put manual filters to it, like news. If you do search on news, you might just search over news on the last 7 days. And then if it's within the last 7 days, you increase the score by 20%. If it's older than 7 days, you decrease it by 10% or so. So there are like a lot of manual hacks employed by developers and building these systems.
So like these are like heuristic, manual heuristics that are set.
Correct. So it's manual heuristics put in by developers. So developer know what's the application, knows what's the recency bias, and then says, okay, if it's recent, increase the score by 20%. I
see. Third question was regarding training retrievers that are good enough when we reduce the amount of like from float to binary ones, right? So you mentioned that you can train models in order to have a uniformly distributed vector representation. so that when we round them off the binary format, it doesn't lose its performance. So how do you force a model to get a uniform vector representation learning?
Yeah. There are different ways. The most simple is you put it as part of the training. So you not only train with like embeddings in the float dimension, but you also have like a loss with the embeddings in binary dimension. And then you do kind of like a backprop. So the model learns itself. Should be good in float embeddings, but it should also be good in binary embeddings. And then you balance these two. So sometimes you see a trade-off, like can be like very good in float, but terrible in binary, or it's like a balance of these two. And then you tune the parameters to say, okay, this is like a trade-off I'm happy with.
So it's like a manual process. You have to iterate over different parameters, like a hyperparameter tuning task.
Correct. So it's a hyperparameter. You generate a lot of models, and at the end, you pick a model that's the most preferred.
I see. Thanks, Nils. That's all from my side.
Cool. Yeah, well, I think we have Gustavo next.
Yes, thanks for the opportunity. Can you hear me?
Yeah.
Okay. So, quick question. I would like to see from your point of view if you think that models are good enough to tag the good or the worst positive case. So, for example, you say to us that you have like better negatives, harder negatives with retrieval information. Do you think that models could, in an automatic way, predict what is a better negative or what is a better positive to scale up the process to annotate data?
Mm-hmm. Yes, so the teacher is good in verifying triplets. So if you give an LM, hey, this is question, this is document A, this is document B, please reason, is A or B more relevant to the question? They work really good. But finding the triplets, we don't have luck yet to automate this because it really depends on the vector space. So I mean, a hard triplet is where the negative is closer to the question than the positive, so it heavily depends on the embedding model. A good triplet for the one embedding model might not be like a good triplet for the other embedding model. And so it's a lot of like brute force, kind of like testing a lot of triplets that might be a fit. Humans looking at it, having an understanding, hey, we're not good yet. Not good at certain use case, and then you look for like triplets in this certain use case, and then you use the teacher to like verify your triplets.
Okay, so just to clarify your answer, you see that maybe models don't do a good job with this because it's heavily dependent on the vector space of the model that we are trying to instantiate a better model. Yeah.
Yeah. So it's highly dependent on the embedding model, sadly.
Okay. Thank you. Thank you.
Thank you. Cool. Yeah, just to answer some questions from Q&A section. So there was a question, using retrieval plus rerank is better than only retrievers. Yes, rerank makes a massive improvement. You always want to do a rerank. Some enterprises like Amazon Search is doing, I don't know, 60 levels of re-rankers for all type of stuff afterwards. So yeah, definitely check out re-rankers. And then next highest question was, how do vector spaces for images work if I want to search a specific image? It's not really much a difference. So you saw the vector space on the text. Can also replace the text with images that you put like all pet images and all dog images in different corners, and car images and images on, I don't know, food. it's the same process that you say, okay, I have a question, I have a positive image, I have a negative image. If I search for like a cute cat, the cat image is more relevant than the dog image. The only difference is like the model. So instead of like a text transformer, you use an image transformer in the middle. But at the end, it's the same process. And then next question from Q&A, and then we can go back to like live questions. How does one define an authoritative source? Isn't a very huge issue when it comes to political polarization and fairness, also looking for papers on the topic. Yeah, that's a challenge. That's why we also don't have a solution. How do we define which source is authoritative, which source is trustworthiness? Especially in enterprise settings, it's very complex. So an authoritative source can be connected to like the hierarchy. So like what a CEO says is more relevant than what an intern in the company is saying. But there's also like expertise. So people are like topic experts. They know, let's say, databases very well. They've been working on databases for 20 years. And if this database expert says, I don't know, database A is a good choice for the solution, this is more authoritative than, yeah, if someone from like a related field from an outside says, oh yeah, I think database B is a good choice. So it's very hard. No one has a solution for it. Google is doing this on the web a lot. So they go on the web to find authoritative sources. They use a lot like linked networks, like PageRank, like a lot of pages are linking to Wikipedia. Hence, Wikipedia must be trustworthy. Having manual features to say, okay, if it's like from a governmental side or from an educational edu domain, it's more trustworthy. Having annotators go out looking, like especially in the medical domain, to say, oh yeah, this report is trustworthy, this source is less trustworthy. But in an enterprise setting, it's like very hard. Like, I don't know, if you look at emails, it's right now impossible to say which sender is higher in the hierarchy and which sender has like more expertise in a certain domain. Cool. Now we can go to live question. I think Harsh, you're the next one. Harsh is here. Otherwise, Shamima, you would be the next one who have raised their hand.
We can't hear you, Shamima.
So maybe let's try it with Lewis. Can you hear us, Lewis?
Hi, Nils. Can you hear me?
Yeah, I can hear you,
Thanks
Lewis.
for the opportunity, and congratulations for the presentation. I love it. My question is, what's in your opinion, what's the main elements to consider when choosing the suitable embedding models? I think the data on which it was trained, or the size of the model, or what's your opinion about that?
Yeah, I mean, of course, I'm biased. I think Cohere Embed 4 is a great option. But yeah, it's in general hard to say. So again, you have often trade-offs, kind of like quality cost trade-offs. If you take open source embedding models, they're like a lot of very large embedding models, like 8 billion per meter embedding models. That claim to be good. Some are good, but which are like very, very expensive to run at scale. Again, if you want to embed like a lot of text, it makes a difference if you pay $1,000 or $1 million for that. So if you go with open source models, I would look at how good is the quality for my area? It's sadly very hard to assess model quality because a lot of like the benchmarks, like the MTAP benchmark, they are like highly polluted, like models overfitting on it. So they claim to be very good, they are not really good on your use case. So it makes sense to build kind of like your own eval, test different models, and then pick a model that has like a nice trade-off between quality and cost. And yeah, often where you see models struggle is longer context. So a lot of models, they work good on like short context, like 500 tokens. They claim to support something like 8K or 30K, but performance drastically drops after like 1,000 tokens. Multilinguality is an interesting, like, is different languages relevant for you? Cross-lingual is relevant, like if you search in English, do you want to find documents in Chinese as well, or just in English? So it's sadly not very easy to pick a good model.
Thanks so much.
Yeah, welcome. Sohan, you would be the next.
Yeah. Hey, Nils, thank you for your presentation. So following up on your work, do you have any references which I can read to, get a clear idea about what you just presented?
Could you maybe repeat it again? Sorry, the audio was a bit spotty on my side.
Yeah. And following up on your work, do you have any references? Do you recommend any references that I can read to just follow up on your work which you just presented?
So the question was like any related work and resources you can read?
Yeah.
Yeah, I mean, the information retrieval community is very active. People training embedding models, re-rank models, RAG evaluation. So yeah, just, I don't know, look out on archive, good papers there published. Follow the right people on Twitter. So there's a lot of like active research community on Twitter.
Yeah.
And then, yeah, it's constantly changing and evolving. Share tasks, there's like track rec. So more focusing on like rec setups, which are also interesting. So you can follow these competitions, see what people input there as a solution.
Also, like, I had one more question with reference to the embeddings. So we are working on a project where we convert a resume into embeddings. It's like one of the stages. So do you recommend converting a resume into embeddings, or recommend splitting the resume into section skills, education?
Sohan, sorry, I think we're getting poor audio, so I think we're going to have to cut it now. Yeah, sorry about that. And we're coming close to time. But thank you so much for your questions. Nils, thank you so much. Masterclass in this topic area, but also on coordinating between live and written questions. Thank you so much for your time today and a really rich session. Ahmed, do you have notes to close us off?
Yeah, so thank you so much, Nils, for the session. And before closing, I will share the screen and I will invite Mayank. So we will be announcing our 2 upcoming channels that we are starting at Cohere Labs community in our Discord channel. So Mayank will be introducing our newest program, Retrieval and Search subprogram. I'll pass it over to you, Mayank. You can unmute.
Thanks, Ahmed. So hi everyone. I work as a senior machine learning engineer at McKinsey. I work mostly on search and graph ML. So we are starting up a new retrieval and search sub-program at Cohere Lab Open Science community. The main focus areas would be neural information retrieval, representation learning, advances in ranking models, multimodal and multilingual search, recommendation systems, of course. We will talk a lot around quantization and compression techniques as well, evaluation, robustness, and fairness. The kind of activities that we have planned is, of course, we will be discussing the latest papers and the SOTA works on the dense retrieval or sparse retrieval systems, hybrid methods, and advances in representation learning. We'll also try to host monthly or at least bi-monthly open challenges or DIY kind of hands-on projects on several topics. There would be opportunities for mentorship and collaboration, as well as we'll discuss some upcoming benchmarks or already existing benchmarks to support real-world experimentation. You can join the channel through the roles and channel section in the Cohere Labs Discord server. The channel is named Retrieval and Search. Thank you, everyone. Thanks, Emil.
Thank you. And our second new program is ML industry. So I'll let Vaibhavi talk about it, who will be leading the ML industry.
Thank you, Ahmad, for the kind intro. So ML Industry is one program we've come up with to bridge the gap in frontier ML research between the industry and academia. We have observed that Cohere community is open to a lot of people who want to switch from academia to industry, and thus we want to support them through various structures. One is we have planned talks with frontier, leading researchers from DeepMind, FAIR, Mistral, and other research labs in industry. Apart from that, for bringing tangible skills to our audience, we want to hold some workshops which will teach them hands-on skills on APIs and ML product features. Then we also want to introduce the feature of interactivity with the people who we might feel intimidated in approaching ourselves. So we want to bring interactive panels to have discussions on what matters in the industry, what is the difference that academia and industry makes. Yeah, so we would love to hear from you. We are finalizing our speakers for the very first session. Feel free to join our channel at #MLindustry and give yourselves the roles in the Discord channel to get the notifications. Thank you, everyone.
Thank you, everyone, and thank you so much to our guest speaker Nils for the session. To the questions in Q&A, especially related to our Discord channel, we verify each application before adding you to our Discord. So it takes some time. So please be patient regarding that, and you will probably get it in a week or two. Thank you so much, and looking forward to see you all tomorrow for our next session that is on introduction to transformer and evolution of large language models. So we'll see you tomorrow. Thank you so much, everyone. Take care, and I'll end the session here. Bye.